Alright, welcome back, and let's talk about domain modeling. I have my notes here, and let's start. So we'll discuss why domain modeling matters, what it is, what are some key patterns for modeling domains, what are entities, value objects, and domain services. So first of all, what is a domain model? A domain model is conceptually the model of the problem space, which is basically the real world things that we're building with our applications. So a domain model can represent things in our business model. They're also called entities. It can represent relationships between them and certain rules that or behaviors that they might follow. Basically, it's just a way of thinking about the data and logic of our application from a real world perspective. It's not how it's stored in the machines or displayed or processed. It's just the way how we think about data. So an example of this would be, let's say we are building a library system. Our domain problem is solving how to store libraries, how to store books and keep them managed in your libraries. And our domain model might include entities such as books, members, loans, and these are real world things which are modeled in code later on. And what the domain model is trying to solve is it's trying to simplify these mental maps of businesses that we have. I worked in a lot of different industries. I worked as a waiter, and basically you have these complex procedures for, I don't know, making an espresso or something like this, which you simplify into a domain, basically saying, oh, step 1, put the filter in it, step 2, press these buttons, add coffee, add milk, add water, stuff like that. Press the button. We simplified to just represent coffee. So it's just a way to simplify the mundane world of business to people who implement applications that are helping these certain businesses. And the people who own the businesses, like the stakeholders, they have this certain terminology that they use, which is in their own interpretation of the domain model, where complex ideas and processes are boiled down to a single word or phrase. So we can have an example. For example, let's say we have a sneaker retailer, a fast-growing online sneaker store that sells limited edition and popular sneakers across, I don't know, North America and Europe. So what we have right now is that we have products that are shown as in stock only if they are physically sitting in the warehouse. But if the warehouse runs out of a sneaker, the website lists it as out of stock until more arrive from the supplier. All right, so I've drawn a crude model of it, a crude diagram of it. So basically, what happens? We have items in stock only when they are physically sitting right here in the warehouse. But if the warehouse runs out of a sneaker, the website will list it, and the website is this. The e-commerce site is gonna list it as out of stock. So what we want to do is the following. We want to sell incoming sneakers too, even though that they are currently on the way from the manufacturer or being processed as the comments. So we have the suppliers, and they are bringing new sneakers into the inventory as well. And the system will calculate estimated arrival dates from supplier data, so customers can still order sneakers which are marked available soon. So in order to understand and to explore the domain module, it takes some time. So in order for this all to work, we have to express the business ideas into our own local jargon. And we take these identifiers, such as customers, e-commerce, inventory, warehouse, and suppliers, so that the examples are easier to talk about. All right, let's open the coding environment we want. Not this. So what we have here is a unit test. The name of a unit test describes the behavior that we want to see from the system, and we have the names of the classes and the variables that are taken from the business jargon. And we can show this code to non-technical coworkers, and they would agree that this correctly describes the behavior of the system. Now, let's create the domain model for this. I don't need this. Can I delete this somehow? Delete cell. No, again. Markdown. All right, now let's write the first version of our domain model. We will have the order line, order ID will be string, SKU. SKU is the stock keeping unit. It's a unique product code used to identify a specific type of a product, in our case, a sneaker. So we can have, I don't know, like here, Jordan 1 retros. So what else do we have? Quantity, it's an integer. I'm just gonna put here about the class a decorator of frozen true. It's a decorator from the Python data class module, and it does two important things. It automatically generates common methods for your class, like init, which is the constructor, the string representation, the equality comparison, and it's really useful for classes that mainly store data, like our order line. And the frozen equals true, it makes the instance immutable, which means once you create an object, you cannot change its fields. So once, for example, let me just add it here. So for example, we can't do the following. I can't create an object and then say line equals quantity is 5. This is not allowed. All right, let me just add the required imports here. All right. Oh, we don't have a formatter. Okay, let me just save this. So here we have it. Order line is a class. It's an immutable data class with no behavior. You might wonder, why is the order line frozen and the batches? Because from the domain module's perspective, order line is a customer's request for a specific product and quantity. It's just data. It shouldn't change. The customer ordered this, and that's that. So making it immutable ensures it's safe to pass around. But the batch is not frozen because it's an active part of our system that tracks the available quantity. Might be later extended to deallocate or update or change stuff around. and it needs mutable internal state to function properly, so we don't freeze this specific class. I'll just move. Can I move this? Can I move? No. Cut cell. I can paste here. Paste. Nice. Now, let's write some more failing tests. All right, we have some extra tests here now. And if I run the above cells, if I run these cells now, I think they are gonna fail. Why do I have this? Is I clicked the debugger. I don't want to click the debugger. I want to run it immediately. So what we need to do, we need to implement, first of all, we refactor our test suite. So we have some new tests for a new method, which is called canAllocate. And the names we use mirror the language of our domain experts. And the examples we agreed upon are like directly written in code. Now we can implement and write the canAllocate method of the batch class. So what do we have here? Can allocate self. We have the order line. Where is the where to? I missed the comma here. And now this should work, and the test should be okay as well. So this method canAllocate is a way for us, for the system to check, can I fulfill this order from this batch? And it returns true or false, depending on two things. It checks whether we are talking about the same products, and because we can't allocate, I don't know, a Yeezy to an order for a Jordan, and do we have enough in this batch to cover the order? And only if both conditions are true, this method will return true. And in real life, let's say we have 10 what? Let's say we have 10 pairs of Nike Air Maxes. And the customer orders 2 pairs. So the canAllocate will check for it and it will return true. But if they order 12 pairs, then we will return false. With this, we can keep the business rules separate and usable. And our tests can simulate behavior without changing state at all. So let's remove this. I just noticed something that I need to fix. I'm writing everything in a Python Jupyter notebook, but I want to be able to run my tests. So what I'm gonna do, I'm gonna create a new project here. It's gonna call domain modeling. I'm gonna create a new file called model.py, copy everything from here, do this as well, create a new file called tests.py, paste all of this here, and now maybe I could also create a make file so we can run the tests automatically. I want to install the recommended makefile tools. Okay, let's do this. Do I need this? Well, probably not, but let's do this. So tests, where are you? Here, domain modeling. So let's do this. I'll just rename this because PyTest needs a certain files, such as these. PyTest needs to have files, test files to be defined with the test, starting with the test string and having an underscore here as well. So now, if I open, what's this? It's Copilot. I don't need it. So terminal. So if I do here, if I go to domain modeling and I say make test, no such file or directory. Let's see if let's install PyTest. And now if I run make test, so these guys are failing, and they are failing because batch is not defined. A batch is not defined because I need to import you, my good friend. this. I don't need PyTest here. I don't need this. I don't need this as well. So I've imported everything, and now 5 passed. All right, everything is good now. Let me just close the terminal so we have more place to work with. All right, let's update the batch class. The constructor we won't touch, but here we're gonna add an allocation. It's gonna be a set. So if we can allocate, what I'm gonna do, oops, I don't need this. If self can allocate, let's add the line here. This. Let's add some properties. So let's update the batch class. We actually already updated it. We updated it with code to properly track which orders have been allocated, rather than just subscribing them from available quantity manually, which makes the logic kind of more realistic and easier to test or manage. So we added this line right here, which creates a private set. And by convention, anything starting with an underscore means for internal use. And this will store all order line objects that have been allocated to this batch. So maybe we can think of this as a notebook where the warehouse writes down every order that we reserved sneakers for. And why do we use a set? Because it has an incredibly fast lookup, and automatically it avoids duplicates. Basically, we can't allocate the same line twice. Then we have allocate and deallocate methods, which only add the order line if we can allocate it. If we have enough stock and the same skew. We don't reduce quantity directly anymore, as you see here. We track allocations in the private variable allocation. And also we have the allocate, which only removes this order if it was already allocated. What else do we have? The property decorator. These are Python's ways of saying we can access this as a variable. So what do we have? We have one property here. Again, as I mentioned, the property decorator says, okay, you can access this method as a variable. So instead of writing batch.availableQuantity as a method, we can just write batch.availableQuantity as a property. The first method allocated, the first property actually allocated quantity adds up all the order quantities that have been allocated. So we have sum for all the lines in the allocation. We are looking at the quantity, we are summing them. So it basically says how many seekers in total have I promised to the customers. And then we have the available quantity, which calculates how many are left for new orders. Also, I might see you scratching your head and asking, what is this? What is the purchase quantity doing? Which is this property right here. Now our batch actually, let me just show this as well. Let me maybe just have a more direct color. Now we have a class, batch, which will keep track of a set of allocated order line objects, which is another class, order line, like here. I'm just gonna add another test here. Which tests whether we can only deallocate allocated lines. All right.